Good morning, learners and viewers. Welcome to the session for quantitative analysis for managerial application. Today we will be discussing about block 4, which is forecasting methods, and it has four units in it: business forecasting, correlation, regression, and time series analysis. So we will start with unit 13, that is business forecasting. In today's highly dynamic business environment, managers have to forecast the future and design strategies accordingly. The success of business depends mainly on future planning based on past and present experiences. The experiences may be based on quantitative and or qualitative factors. Both these types of information helps managers in business forecasting. Managers use forecasting techniques to make strategic decisions about selling, buying, hiring, etc. in everyday work. The past data are used by managers to make predictions about the future. Forecasting is essential in order to make reliable and accurate estimates of what will happen in future in the face of uncertainty. A flowchart of forecasts and the decision-making process is shown. We can see that we have starting from the strategies, decisions, planned performances, and monitoring system. And decision and monitoring systems are again showing the actual performances. And from monitoring systems, we get divergence and then we forecast it. And lastly, the forecasts are made, then strategies are developed. Decisions are also get influenced by the additional information obtained by using the forecasting method. Such information and the perceived accuracy of the forecast may also affect the strategy formulation of an organization. Thus, we can say that an organization needs to establish a monitoring system to compare planned performance with the actual. Some of the objectives of forecasting are creation of plan of action, because it is not possible to evolve a system of business control without an acceptable system of forecasting. Monitoring the continuing process of action, plans based on forecasts. Thirdly, the forecast provides a warning system of the critical factors to be mentioned regularly, because they might drastically affect the performance of the plan. Now, the thing is that what is the distinction about prediction, projection, and forecasting? Prediction is a future estimate based on extrapolation. Hence, we can say that prediction is solely based on past data of the series under investigation. As far as projection is concerned, it is a prediction where an extrapolated value is subject to certain assumptions. And lastly, we come to forecast. A forecast is an estimate for some future point of time, partly based on past and present data, and partly on subjective estimates arising of the experience and judgment of the forecaster. What are the steps in business forecasting? There are various steps, but we will be discussing some of them. To start with, to know the causes of changes in the past. While attempting to forecast business fluctuations, a clear understanding about the causes responsible for past changes is a must. Secondly, to measure the phases of business activity. Having known the cause of occurrence or fluctuation, certain phases of business activity needs to be computed so as to forecast the changes which are supposed to occur after the current level of activity. Thirdly, it is selection and comparison of data. The business barometers form the basis of statistical and data available for measuring the fluctuations in business activity. And lastly is the analysis of the data. The data need to be analyzed in the light of one's understanding of the reason why changes occur. If it is known that certain factors have resulted in a given change, then these factors have to be computed statistically to draw conclusions about the future. What are the methods of business forecasting? The methods of forecasting can be classified into two broad categories. The first one is quantitative or objective, and the second one is qualitative or subjective. Further, these are this is a very broad stream, but we are taking some of the major methods of making the forecast. As discussed, forecasting methods can be divided into two branches, that is qualitative and the other one is quantitative. If we talk about qualitative, that includes personal opinion or judgments, panel consensus, Delphi method, market research, and historical comparison. And if we talk in terms of qualitative, it has two branches. First one is time series, and the second one is casual. If we talk about time series, that includes freehand method, smoothing method, trend projection methods, exponential smoothing methods, auto regression model, and Box Jenkins model. And if we talk about the casual method, it is leading indicators, regression analysis, input output analysis, and econometric model. So we will be discussing some of them in our discussion today. If we talk about qualitative forecasting methods, these methods consist of collecting the opinion and judgments of individuals who are expected to have the best knowledge of current activities or future plans of the organization. An important advantage of qualitative method is that they are easily understood. Another advantage is that they can be incorporate subjective experiences as inputs along with objective data. Again, the cost involved in forecasting is quite low. These methods have some limitations also. One serious limitation is the varying perception of people involved in forecasting. Because different people have different opinion about a subject. As a result, intuitive forecasts are likely to differ from one individual to another, and the wide variance is found in forecasts. These methods are suitable when forecasts are to be made on highly technical products which have a limited number of customers. Then comes the personal opinion. Here, an individual does some forecast which can be relatively reliable and accurate of the future on the basis of his or her personal judgment without using a formal quantitative model. This approach is usually recommended when conditions in the past are not likely. to hold in the future. Then comes panel consensus. To reduce the prejudice and ignorance that may arise in the individual judgment, it is possible to develop consensus among groups of individuals. Such a panel of individuals is encouraged to share information, opinion, and assumptions to predict future value of some variable understood. Then comes the most important, what people by industries are using, that is Delphi method. This method is very similar to personal consensus method. In the Delphi method, a group of experts who may be stationed at different locations and who do not interact with each other is constituted. After this, a questionnaire is sent to each expert to seek his opinion about the matter under investigation. A summary is prepared on the basis of written questionnaires from the experts. On the basis of the summary, a few more questions are to be included in the questionnaire, and this modified questionnaire is again sent back to the experts. This process, which generally keeps them informed of each other's forecasts, is repeated until that desirable consensus is reached. The Delphi method is an iterative procedure in which revisions are carried out by the experts till the coordinator gets a stable response. The method is very efficient if properly conducted, as it provides a systematic framework for collecting expert opinion by virtue of anonymity, statistical analysis, and feedback of the results and provisions for forecast revisions. Results obtained are free of bias and generally reliable. Then comes your market research. The marketing research method is introduced in order to collect data, and accordingly, a well designed questionnaire is prepared and distributed among the respondents. On the basis of the response obtained, a summary is prepared and the survey result is developed. Delphi method is very similar to, in this method, a group of experts, we have already discussed this. Then comes your quantitative forecasting methods. These forecasting methods can be used under the following situations. Past information about the variable being forecast is available. Secondly, available information can be expressed numerically. And thirdly, a reasonable assumption is that the pattern of the past will continue into the future. Forecasting for medium and short-term decisions. Forecasting for medium and short-term horizons from 1 to 6 months ahead is commonly employed for production planning, scheduling, and financial planning decisions in an organization. We can classify these methods into 5 categories. First one is subjective of intuitive methods. Second one is methods based on averaging of past data. Third one, regression model on historical data. Fourth one, casual or econometric models. Fifth one is schematic models with time series analysis and box tendency model. We will be discussing this thing in our discussion today. We'll start with subjective or intuitive methods. These methods rely on the opinion of the concerned people and are quite popular in practice. Top executives, salesmen, distributors, and consumers could all be approached to give an estimate of the future demand of a product. And a judicious aggregation or adjustment of these opinions could be used to arrive at the forecast of future demand. Committees or even a Delphi panel could be constituted for this purpose. However, all such methods suffer from individual bias and subjectivity. It cannot be documented and programmed for use on a computer so that no matter whether A, B, or C makes a forecast, the result is the same. However, subjective and intuitive methods have their own advantages. Marketing or other functional areas may be the only method available to forecast and plan future operations. Then comes your methods based on averaging of past data. Exponential smoothing methods is the method which is employed. Now, the thing is that what this method consists of, what is what all about? Exponential smoothing is another technique used to smooth a time series of its sharp variations. It is a type of moving average forecasting technique, which consists of a series of exponentially weighted moving averages. The exponential smoothing method weigh data from the previous time period with exponentially decreasing importance in the forecast. This method has a relative advantage over the methods of moving averages. Firstly, this method focuses upon the most recent data available with us. And secondly, during forecasting, this method takes into account all the observed values because each smoothing value is based upon the values observed previously. This method is used for forecasting when there is no apparent trend or seasonal variation in the given values of a variable. However, this method is useful mostly for short-term forecasting, like forecasting of sales, inventory, price, etc. We have a mathematical relation for it. That is Ft is equal to Ft minus 1 plus alpha times minus dt minus Ft minus 1, which normally when this bracket is opened up, we get alpha t1 plus 1 minus alpha Ft minus 1. And these values all have their meaning, where alpha is a smoothing constant whose value lies between 0 and 1, but generally chosen value lie between 0.01 and 0.3. Higher value of it places more emphasis on recent data. To initiate smoothing, a starting value of Ft is needed, which is generally taken as the first or sub-average demand value available. Another method often used in time series analysis is to identify the following four major components in a time series. The first one is secular trend, which is long-term growth in market. Second one is cyclic fluctuation, which is due to a business cycles. Third one is seasonal variation, which includes regions where demand is seasonal. The fourth one is random or irregular variations. We will see how these four are connected. Then we move to unit 14, that is correlation. Now, first of all, we will understand what is the meaning of correlation. Correlation refers to the association between variables. When an association exists between two variables, it means that the average value of one variable changes as there is a change in the value of the other variable. A correlation is the simplest type of association. When a correlation is weak, it means that the average value of one variable changes only slightly, or we can say only occasionally, in response to changes in the other variable. If there is no association, it means there is no change in the value of one variable and the response to the changes in the other variable. In some cases, the correlation may be positive or it might be negative. If we talk about the positive correlation, that means one variable increases, the other variable increases. That is height of a child and age of a child. That means height of a child will increase with the age, the increase in the age of the child. Similarly, for negative correlation, which means that one variable increases and the other variable decreases. That means the value of a car and the age of a car. Value of a car depreciates, the age of the car increases. What are the causation for correlation? The correlation between two variables measures the strength of relationship between them, but it does not indicate the cause and effect relationship between the variables. Correlation measures covariation, not causation. Then what is meant by causation? Causation means changes in one variable affects or causes the change in the other variable. Or in other words, we can say that just because two events or two things occur together does not imply that one is the cause of the other. But the different types of correlation, positive and negative correlation, and second one is linear and non-linear correlation. If two variable changes in the same direction, that is, if one increases, then the other also increases, or one decreases, or the other also decreases, then this is called a positive correlation. For example, advertising and sales. The more advertisement we do, the more sales what we expect we get. In some other examples of series of positive correlations are height and weight, household income and expenditure. As your income increases, no doubt your expenditures will increase. Price and supply of commodities, amount of rainfall and yield of crops. But secondly, if two variable changes in opposite direction, if that is one increases and the other decreases, or vice versa, this correlation is known as negative correlation. For example, TV registrations and cinema attendance. Some other examples of series of negative correlations are volume and pressure of perfect gas, inversely, current and resistance, keeping the voltage constant, that gives us the Ohm's law, price and demand of goods. Then comes your linear and non-linear correlation. The nature of the graphs gives us the idea of the linear type of correlation between two variables. If the graph is a straight line, the correlation is called a linear correlation. And if graph is not a straight line, the correlation is non-linear or curvilinear. In general, two variables x and y are said to be linearly related if there exists a relationship in the form of y is equal to a plus bx, where a and b are real numbers. This is nothing but a straight line when plotted on a graph with different values of x and y, and for constant values of a and b. What is meant by degree of correlation? Through the coefficient of correlation, we can measure the degree of or extent of the correlation between the two variables. On the basis of the coefficient of correlation, we can also determine whether the correlation is positive or negative, and also its degree or extent. First one is perfect correlation. If two variable changes in same direction and in the same proportion, the correlation between the two is a perfect positive. According to Carl Pearson, the coefficient of correlation in this case is +1. On the other hand, if the variable changes in the opposite direction and with the same proportion, the correlation is perfect negative, and in that case, the coefficient of correlation will be -1. Now, what happens in the absence of correlation? If two series of two variables exhibit no relation between them, or changes one variable does not lead to change in the other variable, then we can firmly say that there is no correlation or absurd correlation between the two variables. In such a case, the coefficient of correlation will be 0. We can conclude that correlation may be positive, negative, or 0, but lies between the limits plus minus 1. Or we can say that the value of r can be written as minus 1 less than equal to r less than equal to 1. The signs plus and minus are used for positive linear correlation and negative linear correlation, respectively. Now, to understand the degree and type of correlation, we have seen we have two types of correlation, positive and negative. Now, how to express the degree? If in case of absence of correlation, the relation will be zero. That means the value of r will be zero in both the cases. If we talk about perfect correlation, so it will have plus one value, and for negative correlation, it will have negative one value. If we talk in terms of high degree of correlation, that means that the value of R will be between 0.75 to 1 with positive direction. And in case of negative, it will be negative 0.75 to minus 1. For moderate correlation, its value will be between plus 0.25 to 0.75 in case of positive one. And in case of negative, it will be minus 0.25 to minus 0.75. If we talk about low degree of correlation, that means it will be in plus side 0 to 0.25, and in minus sign it will be from 0 to minus 0.25. One thing has to be kept in mind that R is a dimensionless quantity. It does not depend on the units employed. What are the different properties of correlation coefficient? The correlation coefficient R lies between minus 1 and plus 1. Correlation coefficient R is a pure number and is independent of the units of measurement of the variables. Thirdly, the correlation coefficient R is independent of change of origin. That is, the value of R is not affected even if each of the individual values of two variables is to increase or decrease by some non-zero constant. Fourthly, the correlation coefficient R is independent of the change of the scale. That is, the value of R is not affected even if each of the individual values of two variables is multiplied or divided by some non-zero constant. What are the different methods of determining correlation? First one is scatter plot. Second one is Carl Pearson coefficient of correlation. Third one is Spearman's Frank correlation coefficient. We normally get numerical on this part because it is analysis of the data given. So we will start with scatter plot. Scatter plot is basically used to graphically investigate the possible relationship between the two variables without calculating any numerical value. So on one x-axis we will be taking one information, and on the y-axis we will be taking the other, and we will be just plotting the values. In this method, the value of two variables are plotted on a graph paper. Here we can see that. On plotting, first one is the perfect positive correlation. You know that in that condition, R will be plus 1. You can see that the line is moving upwards. In second, we can see that there is high degree of positive correlation because the points are scattered in upward direction. We are just concluding and drawing a line between them. We can see that it is having a high degree of positive correlation. Now the third diagram, we can see that the points are scattered. So we can say that there is low degree of positive correlation because the points are moving in upward direction. Now, in the fourth one, we can see that there is the graph, the line is coming down. That is R equal to minus 1. And that is a case of perfect negative correlation. And subsequently, when the graph is coming down and we are finding out a particular line, that means in that case, we can say that high degree of negative correlation. And the last one, we can say that low degree of negative correlation because the points are scattered all over. Here, it's difficult to plot a line. That means we can say in this particular case, scatter diagram, that there is no correlation. In that case, your R will be C. Then comes your Carl Pearson coefficient of correlation. This gives the precise numerical expression for the measure of correlation because initially we started talking about R, the value R. Now we will see how this R is calculated from the given data. It is denoted, the measure of correlation is given by R. The value of R gives the magnitude of correlation and its sign denotes the direction. If for plus it is positive and for minus it is negative. The mathematical formulas used for computing R. The first one is R equal to summation of x and y upon n times standard deviation of x and standard deviation of y. Now the question arises how these values or these notations mean. Small x is equal to x minus x bar. So that means we can say that while calculating Carl Pearson coefficient, we have to calculate mean, then its deviation, mean of x, mean of y, standard deviation of x and standard deviation of y. Then we can apply this formula, summation of x and y upon n times of standard deviation of x and standard deviation of y, where your n is the number of or pairs of observations. Now the question arises how to calculate standard deviation. Standard deviation is under root summation of x squared divided by n. And for under the standard deviation of y, it is under root summation y squared upon n. Now we can conclude, if we see the difference between the two relations, that now we are getting relation in terms of standard deviations. That means R will be equal to summation of xy upon under root summation x squared times under root summation y squared. N is removed from the above formula. Now, there are three methods of calculating R. This depends upon our judgment and the numerical values given in the problem. Depending upon the problem given and the data, we have to apply the formula. If we talk in terms of actual mean, we must straight away, this time we won't be using standard deviation. So in that case, x bar is mean, y bar is mean of y. We will be applying the formula R equal to summation of multiplication of x minus x bar times y minus y bar divided by under root of summation of x minus x bar whole square. This is for x, similarly for the y. If we have assumed mean, normally what we do or what we have studied in our earlier sessions, calculation of mean from assumed mean. In that case, we will be using the formula R equal to summation dx into dy minus summation dx dy upon n. And this whole is divided by, we have to be very careful to remember that there is a difference between summation dx square and summation dx whole square. These two values are different because we get similar values in the problem, but we get confused where to use dx, summation dx square, and where to square summation dx. If we talk in terms of direct method, we can use R equal to n times of summation xy minus summation x to summation y divided by n times of summation x square minus summation x whole square. There is a difference. If we have covariance given in the problem, then we can use this formula. Covariance is equal to some product of Summation product of x minus x bar into y minus y bar divided by n. This is covariance, and in terms of covariance, your formula for Carl Pearson will be R equal to covariance xy upon sigma x, sigma y. Sigma x is standard deviation of x, and sigma y is standard deviation of y. Then comes Spearman's rank correlation coefficient. This method is based on the ranks of the items rather than on the actual values. The advantage of this method over the other is that it can be used when the actual values of items are unknown. For example, if you want to know the correlation between honesty and wisdom of the boys of your class, you can use this method by giving ranks to the boys. It can also be used to find the degree of agreements between judgments of two examiners or two judges. The formula for rank correlation is R is equal to 1 minus 6 times summation d square upon n into n square minus 1, where R is the rank correlation coefficient, d is the difference between the ranks of the two items, and n is the number of correlation. Again, the value of this R will also lie between -1 and +1. If we talk of R equal to +1, it will be having a perfect positive correlation or complete agreement in the same direction, because this is related to the judgment. R is equal to -1, that is perfect negative correlation or complete agreement in the opposite direction. And if R is equal to 0, there is no correlation. Now, how to compute this rank? We are given with the ranks of the values of the item. Generally, the item with the highest value is rank 1, and the others are given rank 2, 3, 4, according to the values in the decreasing order. Because since we are comparing two things, one will be denoted by R1 and the second will be denoted by R2. We have to calculate the differences of the ranks. That means D is equal to R1 minus R2, where R1 is the rank of X and R2 is the rank of the Y. Note that summation of D will be always 0. Then we have to calculate D square, we have to add them, and then we have to apply the formula. We will see how this is done. Following information, find the correlation coefficient between advertisement and expenses and sales volume using Carl Pearson coefficient of correlation method. This is the data. We are talking about 10 firms whose advertisement expenditure in lakhs is given to us, and the sales volume the respective firm is given to us. Now, what will first step? We have to assume that the advertisement expenses are variable denoted by X, and the sales volume is denoted by Y. So we will be transforming this information into a table of form. Here it comes. We have 10 firms. Advertisement cost or expenditure is denoted by X, sales volume by Y. This table, what was given to us, has been converted into a new table. Now, we will sum all this. We will get summation X. We will divide it by number of observations, that is 10. We will get X bar. X bar is equal to summation of X divided by N. Summation of X is 140 and N is 10. That means its mean is 14. As similarly, this process will be applied for Y also. The Y bar is equal to summation of Y upon N. In this case, summation of Y is 580. And when it is divided by 10, we get Y bar equal to 15. You see in the fourth column, this is small x equal to X minus X bar. Our value in the first line, first row is 11, and our X bar is 14. 11 minus 14 is minus 3. Similarly, we will be calculating for all the firms. We will get minus 3, minus 1, 0, 2, 2, 1, 1, 0, minus 1, minus 1. Now, If you remember recall the formula, it is we have to square it, x squared. So we will be squaring minus 3. Minus 3 when it's squared, we get 9. So keep one thing in mind, since we are squaring it, we will get all positive numbers. 9, 1, 0, 4, 4, 1, 1, 0, 1, and 1. We will sum this up. This is summation x squared. Now we move to y minus y bar. We have y bar is 58 and y is 50. 50 minus 58 is minus. Similarly, we will be calculating for all in the y column. We will get minus 8, minus 8, minus 3, 2, 7 till minus 8. And similarly, we will be squaring this. Y square, again, keep one thing in mind, we will get a positive number. We will be adding all this, we get summation y square equal to 360. Now we have to multiply x and y. Keep one thing in mind, this product x and y can be a negative number because we will be calculating small x into small y. Minus 3 into minus 8 is 24. Minus 1 into minus 8 is 8. 0 into any number is 0. 2 into 2 is 4. 2 into 7 is 14. 1 into 7, 7. 1 into 7, 7. 0 multiplied by any number 0. Now, minus 1 multiplied by 2, it's minus 2. And minus 1 multiplied by minus 8 is 8. We will be adding all this. That means we get summation x, y. Now we will go to the formula. Here you see r is equal to summation of x minus x bar into y minus y bar upon under bar whole square into summation y minus y bar whole square. Summation xy is 70, summation x square is 22, summation y square is 360. We don't have to square anything over here because we have already calculated here. 70 upon the product of under root 22 into 360. We get, after solving the under root, we get 88.99, which can be said as 90. So 70 divided by 90 is 0.786. We get a positive. So what we have concluded from this calculation? From the above calculation, it is very clear that there is a high degree of positive correlation because it is greater than plus 0.75 and R value is 0.786 between the two variables. That means increase in advertisement expenses leads to increased sales volume. This is what we have concluded. Then comes your regression. Regression analysis is a statistical method that helps us to analyze and understand the relationship between two or more variables of interest. The process that is adopted to perform regression analysis helps to understand which factors are important and which factors can be ignored and how they are influencing each other. For example, we can say that age and height can be described using a linear regression model. Since a person's height increases as its age increases, they have a linear relationship between them. Regression models are commonly used to stand as a statistical proof of claims regarding everyday facts. A researcher might administer various dosages of a certain drug to patients and observe how their blood pressure is. This can be broadly classified into two types. First one is linear regression, and the second one is logistic regression. Then comes what is the difference between correlation and regression? If we talk about correlation, it is a degree and direction of relationship between two variables. And if we talk here about regression, it measures the nature and extent of average relationship between two or more variables in terms of the original unit of the data. It is a relative measure showing association between the variables. Whereas in regression, it is an absolute measure of the relationship. Thirdly, correlation coefficient is independent of the change of both original and scale. But here, regression coefficient is independent of change of origin but not of the scale. Expression of the relationship between the variables ranges from -1 to +1. But here, in the case of regression, we get two lines. It can be a linear line or a non-linear line. If we talk about a linear line, the relationship will be in the form of y is equal to a plus bx. And if it is a quadratic function, it will be a parabola in nature. As far as correlation is concerned, it is not a forecasting device. Whereas regression is a forecasting device which can be used to predict the value of dependent variable from the given value of independent variable. We will see in a problem. Regression line and regression equations. Regression line and regression equations are used synonymously. Regression equations are algebraic expressions of the regression lines. Now let us consider two variables x and y. If y depends on x, then the results come out in the form of a simple regression. But if we take the case of two variables x and y, we shall have two regression lines as the regression line of x on y and similarly regression line of y on x. The regression line on y on x gives the most probable value of y for a given value of x, and the regression line of x on y gives the most probable value of x for a given value of y. That is why we have two regression lines. However, when there is either perfect or positive negative correlationship between the two variables, the two regressions line will coincide. That means we will have one line only. If the variables are independent, R is 0. The lines of regression are right angles, that means parallel to x-axis and parallel to y-axis. Now, mathematically, how these regression lines are made. Regression line of y on x. This line gives the probable value of y, that is the dependent variable for any given value of independent variable. This line is basically given by y minus y bar is equal to byx into x minus x bar. Y bar is the mean from y, x bar is the mean from x, and byx is the coefficient. We'll see how this by on x is calculated. This can be equated as y is equal to a plus bx. Similarly, for regression of x on y, x minus x bar is equal to bxy. See the change between the two coefficients yx and bxy. When we are talking about the regression line of x and y, x will come first. Bxy times y minus y bar. Similarly, this can be transformed with a single line, that is x is equal to a plus by. In the above two regression lines of regression equations, there are two regression parameters, that is a and b. And a is unknown constant, and b, which is also denoted as byx and bxy, is also another unknown constant, which is probably popularly known as regression coefficients. Since a and b are two unknown constants, fixed numerical values which determine the position of the line completely. The parameters a determines the level of the fitted line, that is the distance of the line directly above or below the origin, and parameter b determines the slope. If you remember the normal form of equation of line, that is y is equal to mx plus c, where m is the slope of the line and c is the y-intercept. So similarly here also, the same thing is applied. The parameter b determines the slope of the line. If the values of constant a and b are okay, the line is completely open. But the question is how to obtain these values. That means we have to apply method of least squares. We will be having the problem in the form of x and y only, and later on we have to develop a line best fitted for it. In terms of x and y, we will be applying summation of x equal to n a plus b summation of y, which will give us first equation. And secondly, we have to apply summation xy equal to a times summation y plus b times summation of y square. And for y on x, we will be replacing x with y. Same method is employed. This above method is popularly known as direct method, which becomes quite cumbersome when the values of x and y are large. In that case, this work can be simplified. Instead of dealing with actual numbers of x and y, we take the deviations of x and y series from the respective mean. This is similarly what I'm talking about, what we did in calculating the mean of large numbers. We have just replaced y minus y bar is equal to byx in times x minus x bar. And for the regression line x on y, x minus x bar bxy times y minus y bar. In this new form of regression equation, we need to compute only one parameter, that is b. This b is also denoted either bxy or byx, which is called the regression coefficient. Now the thing is how to calculate these. Regression coefficient, the quantity b. The regression equation is called the regression coefficient or slope coefficient. Since there are two regression equations, therefore we have two regression coefficients. Regression coefficient of x on y, which is known as bxy, and regression coefficient of y on x is byx. Now, how to calculate these coefficients? If we have, now we have to see that in which form the information is shared with us. If we are given the correlation coefficient and standard deviation, then we will apply bxy equal to r times sigma x upon sigma y. You have to keep one thing in mind. If we are finding bxy, then standard deviation of x will come in the numerator, and standard deviation of y will come in the denominator. Similarly, for byx, it will be r times sigma y upon sigma x. Now, we don't have standard deviation. So straight away, we will be applying direct method, that is bxy equal to n times summation xy minus summation x summation y upon n times summation y square minus summation y whole square. See, again, keep one thing in mind. There is a difference between summation y square and summation y whole square. Similarly, for byx, we will just replacing x with y. When deviations are taken from arithmetic mean, dxy will be equal to summation of xy upon summation y square. And in case of byx, which will be numerator will be same, but denominator will change. Where small x is equal to x minus x bar. X bar is mean. What are the properties of regression coefficient? The coefficient of correlation is a geometric mean of the two regression coefficients. That means R is equal to under root product of bxy and byx. If one of the regression coefficient is greater than unity, the other must be less than unity. Since the value of coefficients of correlation cannot exceed 1, both the regression coefficients will have the same sign. That is, if they will be either positive or negative. In other words, we can say it is not possible that one of the regression coefficient is having minus sign and the other one is having plus sign. The fourth property of the regression coefficient is the coefficient of correlation will have the same sign as that of the regression coefficient. If the regression coefficient has negative sign, then R will also have negative sign. And if the regression coefficient has positive sign, the R will have the positive sign. Now we will see how this is applied. What we have discussed is applied to a numerical problem. After investigation, it is found that demand for automobiles in a city depends mainly, if not entirely, upon the number of families residing in the city. Below are the figures of the sales of automobiles in the 5 cities for the year 2019 and the number of families residing in those cities. We have Belagavi, Bangalore, Hubli, Kalaburagi, and Mangalore. We have the number of families residing, that means number of families in lakhs. And sales of automobiles, thousands. This data is given to us. Now we have to calculate. We have to fit a linear regression line y on x by the least square method. And we have to estimate the sales of the year 2020 for the city Belagavi, which is estimated to have 100 lakh families, assuming that the same relation holds true. What we have discussed in theory, now we will see how it is practically employed in the industry. The data is given for 2020. Discussion is between the five cities, but in this, now the question is, we are taking a year further, that is 2020, and we are talking about Belagavi, and we are thinking that the estimated value of the families in 2020 will be 100. So what will be the automobile sales? Since two data are given to us, x and y is given to us, numbers are short, we are just squaring it, x square and x square. Regression equation of y on x is given by y is equal to a plus bx. This is a normal linear line. Now we have been asked to apply least square method. So for the least square method, we have to apply sigma y equal to na plus b sigma x. And the second equation is sigma xy is equal to a sigma x plus b times sigma x square. Going back to the data, we have already calculated all the values. We have calculated the values for the four columns: summation x, summation y, summation x square, and summation xy. Substituting these values in this equation, we get 141.7 equal to 5a plus 375b. And the second equation is 10849 is equal to 375a plus 28625b. Now, by elimination method, we will be finding out the value of a and b. We get a equal to minus 4.885 and b as 0.443. We will just transforming the value of a and b to the basic equation, that is y is equal to a plus bx. Y is equal to, now your standard equation is y equal to minus 4.885 plus 0.443x. Now, we were supposed to calculate the estimated sales of automobiles in the city Belagavi for the year 2020, where the number of families will be 100 in here. We have x is equal to 100. Just transforming the values, you will get y equal to 39.41. If you go back to the problem, you can see that there is a positive. As the number of families are increasing from 70 to 100, the sales is also increasing from 25 to 35. Means we have a positive correlation between sales and number of families residing in that area. Then comes your time series analysis. A time series is a sequence of data points measured typically at successive times, spaced at uniform time interval. This time interval may be an hour, a week, a month, a year, depending upon the purpose of data collection. Most commonly, a time series is a sequence taken at successive, equally spaced points in time. Thus, it is a sequence of discrete time data. Now, the thing is that what are the examples of time series which is used? Pattern recognition, signal processing, weather forecasting, and earthquake prediction. Time series analysis comprises method for analyzing time series data in order to extract meaningful statistics and other characteristics of the data. It is used to detect pattern of changes in statistical information over a regular interval of time. This pattern helps us in arriving at an estimate for the future so to as to cope with the uncertainty about the future. Time series forecasting is the use of model of forecast future events based on known past events. That is to predict data points before they are reached. An example of time series forecasting is in econometrics is predicting the opening price of stock based on its past performance. That is used in the stock market. Forecasting is an essential tool in strategic planning and decision-making process of an organization. What are the applications of time series? Various applications of time series are economic forecasting, sales forecasting, budgetary analysis, stock market analysis, yield projections, process and quality control, inventory studies, utility studies, sales analysis. The usage of time series models is twofold. First is to obtain an understanding of the underlying forces and structure that produce the observed data, and second is to fit a model and proceed to forecasting, monitoring, or even feedback and feed forward control. Variations in time series. There are four types of changes or variation involved in the time series analysis. These changes are called as components of the time series. These are secular trend or long-term trend, cyclic fluctuations, seasonal variations, and irregular variations. First, we will see what is secular trend or long-term trend. In secular trend, the value of variable tends to increase or decrease over a long period of time. The variable may be a population, sales, cost of living, death rates, and so on. The trend includes steady movement over a fairly long time and does not include short time oscillations. The trend may be in the form of a slow, fast increase or decrease. These changes occur as a result of general tendency of data to increase or decrease as a result of some indefinable influences. This trend is most commonly seen in data related to economics, business, and population. Second one is cyclic fluctuations. The cyclic fluctuations refers to regular swing or pattern that repeats over a long period. Cycles are the upward and downward movements about the trend line over a period of time. The movements are considered cyclic if the fluctuation occurs after a time interval of more than 1 year, or it can be many as 15 to 20 years. And in general, these cycles are not regular. They may have different periods and intensity. The most common example of cyclic fluctuation is business cycle. The cyclic variations are affected by erratic, irregular, and random forces which can be separated to measure their impact accordingly. With this, we will be concluding today's session.